Lecture 16 notes. So long division. So that's this word. So I'm going to use long division to divide polynomials with a monomial or with a binomial. All right. So let's see. So this is called a dividend. So we have 1, 2, 3, 4. We have 4 terms. And the divisor is only 1 term. So we're going to divide each one in the dividend by the divisor. So maybe we could write under this as a fraction, as a rational expression, right? Instead of writing here. So we're going to have this numerator and denominator. Okay, same thing. But this will help us to visualize better. So we're going to divide the first term with the divisor. So we do 10 divided by 2, which is a 5. 10 divided by 2, we get 5. X cubed divided by x. Division of the same base, we subtract the exponents, right? So we get x raised by 3 minus 1, which is a square. For y, we have y squared divided by y. That's just y. Then we'll do the second one. So plus 12 divided by 2. Maybe we separate. Right? So I have finished the division for this one, for the first term. So 10x cubed y squared divided by divisor 2xy, I get a 5x squared y. Right? When I do division, look for the same base, then I subtract the exponents. So the exponent here for x is 1 by default. For y is also 1. So when I divide x cubed with x raised by 1, that's x raised by 3 minus 1, which is x squared. Y squared divided by y, which is y divided by 2 minus 1. So that's just y raised by 1. Well, y raised by 1, we don't bother to write y raised by 1, just y. Now let's do the second one. So the second term is 12x squared y divided by 2xy. So the operation is plus, so we write down plus. 12 divided by 2, we get 6. X squared divided by x, that's just x. Y divided by y, that becomes 1, right? Becomes 1. 6x times 1, still 6x. So we don't really bother to write multiply by 1. So we're done with the second term. So this one is done. Now let's do this one. The operation is subtraction, so we gotta be careful with the operation. So minus a divided by 2, that's 4. X divided by x, that's 1. 4 times 1, still 4. Then y squared divided by y, that's just y. So dividing by, so this one was done. Negative ax y squared divided by 2xy, we got negative 4y. Now we're dividing the last term, negative 2y divided by 2xy. We see 2 divided by 2 becomes 1. 1 times anything will be anything, right? Then y divided by y becomes 1. So I have 1 in the numerator, right? So this becomes a subtraction. 1 in the numerator. What's in the denominator? X, right? We still have this x in the denominator. So this is 1 over x. So be careful with this term. Sometimes this term is tricky. So minus 2y divided by 2xy. 2y over 2y becomes 1. So we have 1 over x. Right? So the first one, so this one, the answer is 5x squared y plus 6x minus 4y minus 1 over x. Now let's see 2. So the first one we're dividing by a monomial, one term, right? Monomial. So the denominator is monomial. Divisor is monomial. Now for 2, we have the divisor to be binomial. So what do? Something called a long division. Yeah, if we do fraction, we do over numerator, then we make the divisor denominator. That won't help us unless we can factor the numerator. If we can factor the numerator, we may do that. But let's do long division. And because we don't know if this one is factorable, probably not. Right? So we make this sign. We put the dividend inside. Then we put the divisor x minus 3 outside. So I'm going to use red color. So I'm going to write it right here. Just ignore the A, the letter A. Okay. So make sure you see this x minus 3. Let me make white. So the divisor is here. X. Ignore the A, letter A there. X minus 3. So basically put the divisor outside this, the sign, the long division sign. All right. So no more here. Now what do? We want to eliminate the dividend inside from left-hand side to the right. So first we focus on 2x cubed. So let me write this divisor on the side also because it's not obvious. So that's x minus 3, the divisor, okay? So the step is, so we have binomial here, divisor is binomial. So we're going to take binomial from here. We're going to consider these two. What we do is we use 2x cubed. We think, okay, what is a 2x cubed divided by, take the leading term, divided by the x, right? For this inside two terms, 2x cubed is a leading term. For the outside, x minus 3, x is a leading term. So we divide those two leading terms. What do we get? 2 divided by 1, because by default that's 1, that's 2. Right, so we put on top of the second term, 2. Then x cubed divided by x, we get x squared, right, as a quotient. So we'll put over here, we'll put it on top of the second one. Now, when we multiply 2x squared times x, of course, we get 2x cubed here, right? 2x cubed. Then we want to multiply -3 with this one because we have a binomial here. -3 times 2x squared, we get a 6, negative, right? Negative times positive, we get negative 6x squared. Now what do? Okay, we get those two terms. Now we subtract. We subtract those two from the top. And of course, 2x cubed, subtract 2x cubed, that becomes 0. If it's 0, we don't really need to write it. We just ignore it, 0. Then the second term, we have negative 11x squared minus negative 6x squared. Minus negative become plus. Those two are like terms. So what is negative 11 plus 5? Plus 6. That's positive 5, right? Let's make a line here. So negative 11 plus positive 6, we get negative 5. Then those two are like terms. So x squared, we keep writing x squared. Now what do? So we subtract already, we get negative 5x squared from there, and the leading term cancel to be 0. Now we move the next term down. The next term is plus 11x. So we write down here. Then we do the same process. So we think, let me use blue color. Now the leading term here is negative 5x squared. We use negative 5x squared divided by the leading term of x. Each time we divide by this leading term x. Negative 5x squared divided by x, that's negative 5x, isn't it? So we put negative 5x on top, which is a quotient. Quotient, a place for quotient. The negative 5x times x, of course, is negative 5x squared. Then we multiply negative 5x with negative 3. Negative times negative become positive. So we got a positive 15x. Now do you see the pattern? The pattern is we want to get rid of these terms one by one from the left. So now, if we do a subtraction here, we get rid of the leading term of negative 5x squared from here. So first step, we got rid of 2x cubed. Second step, we got rid of negative 5x squared. Now we have 11x minus 15x. That's negative 14x. What do we do next? We move next term down, positive 12. Oops. We move positive 12 down here. So plus 12. Now we need to put a negative 14 in the quotient, because negative 14 times x give us negative 14x. Then negative 3 times negative 14, negative times negative become positive. 3 times 14, that's 42. Now we subtract. Subtract, we got rid of the leading term in this case. We have 12 minus 42. That's negative 30. 12 minus 42, negative 30, right? Now, do we have more terms? No, we don't have any more terms. So we're done. We're done because negative 30 is has a lower degree than the divisor. The divisor is a degree 1 polynomial. The remainder here, negative 30, is a polynomial of degree 0. So it's a lower degree than the divisor, so we're done. So negative 30 is the remainder. So how would we write our answer? We will write our answer as the quotient, right? In the quotient place, we have 2x squared minus 5x minus 14. Now, we have this remainder. The remainder is not negative 30, right? If it's negative 30, we can combine with negative 14. We have to write this way. We have to write a negative 30 divided by the divisor, divided by x minus 3. So this is to show the negative 30 is a remainder. And this is the quotient. This is the remainder. Okay, now let's see B. For B, we have x raised by 4, x raised by 3. We're missing x raised by square and x. So when we do that, we need to write a 0 to take the place for those terms. So again, we put x raised by 4 inside. We put x plus x cubed. We don't have x squared, so we plus 0 for x squared, plus another 0 for x, then minus 1. So we write this polynomial in order. Then the divisor is x plus 2. We do the same process, right? Same process. So we're taking those two terms, x raised by 4 and x raised by 3. We use the leading term, x raised by 4, divided by leading term in the divisor, x. X raised by 4 divided by x cubed, isn't it? Because x cubed times x, that gives us x raised by 4. Then we need to multiply x cubed with 2. Oh, that's 2x cubed. Let me type, it's too difficult to write with my finger. So plus 2x cubed. Remember, what's the next step? What do we do with this? We subtract, right? When we subtract, remember to give a parenthesis because we're subtracting two terms. So of course, x raised by 4, subtract x raised by 4 becomes 0. Eliminated. Now x cubed minus 2x cubed give us negative x cubed, right? Because x cubed is 1x cubed minus 2x cubed. That's negative 1x cubed. Then we put next one down. What's next term? Next term, x squared. We don't have x squared, so we put 0 here. Now we use a negative x cubed to divide by x. Oh, that's negative x squared. Negative x squared times x, that's negative x cubed. Then we multiply 2 with negative x squared, that's negative 2x squared. Now you see why we need to put 0 there. Because we need to save the spot for x squared term. Now we subtract. When we subtract the leading term here, cancel to be 0. So I have 0 minus negative 2x squared. 0 minus negative become 0 plus 2x squared. So that becomes 2x squared. Then we pull the next down. The x term is also 0. So 2x squared divided by x, that's positive 2x. So then 2x times 2x times x, we get 2x squared. Then we have to do 2 times 2x, which give us 4x. Then we subtract. Again, when we subtract, the leading term goes away. 0 minus 4x, we get negative 4x. Now what do we need in the quotient? We need a negative 4, right? Let's extend this one. Because negative 4 times x is negative 4x. Oh, also we need to move this one down. The last term is negative 1, right? We move negative 1 down. So negative 4x divided by x, that's negative 4. So we put negative 4 in the quotient. Negative 4 times x, we get negative 4x. And then we have 2 times negative 4, give us negative 8. Then we subtract. So each step we subtract. Because when we subtract, we get rid of the leading term. Then we have negative 1 minus negative 8. Negative 1 minus negative 8 becomes negative 1 plus 8. Right? That becomes 7. So how do we write our answer for this? We write equals to the quotient x cubed minus x squared minus x squared plus 2x minus 4. How do we write our remainder? We have to write plus 7 divided by the divisor, x plus 2. This to show 7 is the remainder. Okay. Question 3, type 3 was solving rational equations. Let's say 8. For 8, we see we have one rational expression on the left, one rational expression on the right. So something called a cross multiplication. Let's see, you have this. 1/2 equals to 5/10, right? We know this is true because 5/10 is half when we simplify. So how do we prove this? We could use cross multiplication. Cross multiplication is saying do the cross multiplying. So 1 times 10 equals to 2 times 5, right? 1 times 10 is 10, 2 times 5 is 10. So that means with these two, we can do this. We can do 4 times x minus 2. That equals to 3 times x minus 3. Right. So let's do that. So 3 times x minus 3, that equals to 4 times x minus 2. And this is called a cross multiplication. Now we distribute. So we distribute 3 to x minus 3, get 9 minus 3x. We distribute 4 to x minus 2, get 4x minus 8. Right? Now, we want to combine like terms, but our like terms on two sides, not on the same side. So what do? We need to move around. Okay. Maybe we move 3x to this side. Remember, when we move, we only change the signs. Or it's the same to say, well, let's add 3x on both sides. Same time, let's add negative a on both sides. Or to think, let's move negative a to the other side. Negative become positive. Or it's exactly the same as saying, let's add a on both sides. Add a, this is gone. Add negative 3x, that's gone. So now we can combine like terms because the like term is on the same side now. A plus 9, 17 equals to 4x plus 3x, 7x. Right, now let's divide by 7 on both sides. For equation, I can write x on any side. So now I write x on this side. So normally, by convention, we like to write x term, the variable on the left-hand side. So x equals 17 divided by 7. And that's it. So for this one, because we only have one rational expression on each side, so we can apply cross multiplication. Now B is different. We won't be able to do that, right? B, we see the left-hand side, we have two terms. By one term, we have two terms, we also have two terms. So if we, so one way we could do is we could make those two have a common denominators, right? So let's consider this as a factor, x minus 5 as a factor, and x plus 1 as a factor. Well, x minus 5 is a linear expression, and also it's a prime expression. It cannot be simplified or factored anymore. X plus 1, same thing. So to make common denominator for the first one, we just multiply x plus 1 divides itself, right? Because with the expression, we can only multiply by 1. Now 1 is a transformer, which means 1 can be anything divides itself. So we're going to multiply 1 for this case, which is x plus 1 divides itself. Similarly, for this term, we're going to multiply by 1, but this one is different from the previous one. This one is x minus 5 divides itself. So we multiply x minus 5 in the numerator, and then we multiply x minus 5 in the denominator. Right? Then we just multiply by 1, because x minus 5 divides x minus 5, that's 1. Okay, let's just do that. So the numerator for the first term, we have 3x times x plus 1, which give us a 3x squared plus 3x, right? Then minus the second one, we have 2x times x minus 5. So 2x, maybe let me just write it one more time, 2x minus. So let me read it one more time, actually. Let me not do everything in one shot. So 3x times x plus 1 as a numerator of the first one. I have 2x times x minus 5 as a numerator for the second term. Now, because those two have a common denominator, so I don't have to write twice. I can only write it once. What's the common denominator? X plus 1. And x minus 5, isn't it? Right? So they have common denominator. So I just perform the operation subtraction with the numerators. Now the other side, I don't need to do anything yet. So let's equals to the other side. Okay, the other side still this. I don't need to do anything with the other side. Now let's simplify the numerators. So I have 3x squared plus 3x minus 2x squared plus then minus 2x times minus 5, that becomes plus 10x, right? My denominator will be the same. I don't want, my denominator, maybe I can multiply out, right? If I multiply x plus 1 with x minus 5, I get x squared minus 5 plus 1, that's minus 4. My middle term is minus 4x. Positive 1 times negative 5. My constant term is negative 5, right? Then this equals to the right-hand side. Equals to the right-hand side. Well, let's compare the denominators. Although the denominators are exactly the same. The right-hand side has a denominator of x squared minus 4x minus 5, right? That means the numerator has to be the same. If the denominator is the same, the numerator has to be the same, right? Just like if I have 3 minus 1 over 2 equals to 2. Oh, that's a bad example. Let me see this 3. 3 minus 1, 2. So 3 over 2, right? 3 equals 3. So 3 minus 1 equals 2. So if the denominator is the same, the numerator has to be the same. Okay, let's simplify the left-hand side a little bit. So the numerator will have 3x squared minus 2x squared, which gives us just x squared. We have plus 3x plus 10x, that gives us 13x. And the right-hand side is just negative 42. They have to be equal to each other, the numerators, because the denominators are the same. Now we see we have a quadratic equation. To solve quadratic equation, we want to move everything to be on the one side. So we move negative 42 to the other side, become plus 42. Or to see add 42 on both sides. Now we want to factor this quadratic by thinking 2 factors of 42 adds up to be 13. Oh, I'm missing x term here. That's x after, oops, after 13, yeah. X squared plus 13x plus 42. So 2 factors of 42 adds up to be the 13. 6 and 7, isn't it? 6 times 7 is 42, and 6 plus 7 is 13. So that means this can be factored as x plus 6 and x plus 7, because every term is positive. To solve this, I use zero property. Zero property saying if a product of a couple of things to be 0, that means each one can be 0, or some of them to be 0, or all of them to be 0. Basically, we take this, anyone can be 0. Solve this, we move positive 6 to the right-hand side, or we subtract negative 6 on both hands side. So we get answers of negative 6, negative 7. So 2 solutions for B. All right. And also in class, I mentioned we can multiply by the common denominator, least common denominator. Remember that? We mentioned, okay, we can always multiply both sides by the least common denominator when we figure out what is the least common denominator. So for the first one, we see the least common denominator, it's x minus 2 times x minus 3, right? If we multiply x minus 2, x minus 3 on both sides, we see exactly, we'll get this step. Let me choose a color. Exactly, we'll get this step. Because x minus 2 divides x minus 2, that becomes 1. So we're left with 3 times x minus 3. If we multiply on the right-hand side, x minus the least common denominator, the x minus 3 divided by x minus 3 becomes 1. We're left with x minus 2 times 4. So exactly this. So it's similarly for this one. So for the second one, we can figure out that least common denominator is x minus 5 times x plus 1. Because x squared minus 4x minus 5 on the right-hand side is exactly same as x minus 5, x plus 1. So we can multiply this least common denominator on both sides. On both sides, so the right-hand side, we will get rid of this one. On the left-hand side, we will, we won't have this one. We will get exactly this equals to 42, equals to negative 42 right away. So if we apply that method, we got rid of the denominators right away. But either way works, all right?